How many calories does this infinite triangle have? This is a cookie triangle. It currently has 640 calories. If we cut it in 4 equal pieces and take away 1, it will now have 480 calories. Do it again, we get 360 calories. Again, we get 270 calories, and again, and again, and again, forever. We will eventually be left with something that's called Sierspiński Triangle. But if you were to eat it, how many calories will you gain? This question was used in a Harvard interview. Only the students that got it right were accepted into Harvard. So, what's the answer? Is it A, 0 calories, B, more than 0 calories, C, infinite calories, or D, minus infinite calories? In order to calculate the results, we would have to do an infinite number of steps, and no human is capable of that. So I wrote this program in Python to calculate the results for us. But even with the best supercomputers, we could never calculate an infinite number of steps. So this means we could never know the answer. Unless there was a shortcut. This square has an area of 1. We can duplicate it and cut it in half and add it to our big square. We can duplicate the small shape, cut it in half and add it to our 2 shapes. We do this pattern forever and eventually looks like these shapes combined form a new shape with an area of 2. But how can we know that for sure? Well, let's call this new shape S. If we add the squares together with the same size, we get 2 plus a shape that looks exactly like the S we started from. That's because it is exactly S. And now we have a simple equation. S plus S equals 2 plus S. Subtract both sides by S and we get S equals 2. So this whole shape has an area of 2. To solve this problem traditionally, we are required to do an infinite number of calculations. But by applying clever logic, we discovered the shortcut. We can solve a triangle problem in similar fashion. Let's call this triangle T. Take only the top part of it, zoom in, and notice how this shape looks exactly like the original one, even though it's 3 times smaller. So we get the equation T plus T plus T equals T. This equation is only true when T has a value of 0. So the answer to the Harvard's problem was A, 0 calories.